is interoperability challenges between GIS, CAD, CFD based modeling in open source geospatial ecosystems. Here three different domains I am going to talk, and what are the challenges I am facing and how I am trying to overcome. That is the main thing. So my presentation includes just 4 major parts: introduction, case study, what made to me to go to a case study, and what are the findings I experienced, and single point of conclusions. Let me go to the introduction. Under introduction, I am defining a problem. The problem definition is the geometry of a STL file derived from a shape file is compatible to a CFD model. It's really difficult to understand this problem. I'll explain. Once again, I'll read. Is the geometry of STL file derived from shapefile? The shapefile is the source. Is compatible for fluid dynamics. So for that, to understand this problem, you should know what is STL file. That is most important. So let me explain what is STL file. STL file is one of the file format dominantly used in 3D printing as well as computational fluid dynamics. These two fields, if you want to work, you have to use STL file. And with this is the input, it will take both this domain. And stereolithography file is a 3D model of surface geometry of object that has been studied. In my case, what is my object is urban modeling. So each building is become my object. So I have given few examples here. Okay. And I have given few examples here. What is the status of STL file? It is a simple ordinary STL file without much geometry. When you increase the geometry, each and every curvatures and features will be captured in high-end geometry STL file. This is most important for scientific studies. So even a brain can be stimulated using a STL file. So let us take, we always geographers, we deals if our earth is divided into one side as GIS, normal GIS file and STL file, how it looks. This is nothing but lat long and Z value. This is actually STL file. It's a very lower version of STL file it is. So STL file is almost, I can say, let us take 1 kilometer by 1 kilometer take. If I take a shape file, it hardly takes less than 1 MB. The same 1 kilometer file with the objects, if I take STL file, it will go near to terabytes with objects. That object may be urban and all the features. It will go enormous. That much of geometry is required for analysis. So now I hope the problem is been understood. So I will be talking about GIS, CAD, and CFD. Under GIS, the main technology is topology. The topology has to be retained everywhere, then only the GIS work. Under CAD, it is geometry. You need to for anything, you need geometry. Under CFD, it is fluid dynamics modeling. That means 200 plus fluid flow algorithms are there. So technically, it is called solvers. The right word is solvers. And then some pre-processing technique, which I will cover. So these three domains, is there any case study? So why this case study is required? I'll tell you why it is required. Suddenly we get a query from Government of India. Next week there is the Parliament gathering. What will be the air pollution over the Parliament? We will get next week. Suddenly, okay, what is the input is required? The shape file of Parliament layout, that means we call as an area, and STL file of Parliament, that means each buildings is main primary input to compute the pollution dispersion over the particular area. So any flow dynamics, anything, such type of CAD study is done. It is pollution dispersion. This can be a dam break model also. Our Indian dams at borders are in the line of sight of enemies. Something happens. At what rate the flood will happen, at what velocity. the exact word is velocity when it comes to fluid dynamics. When it comes to GIS, it comes at what rate it spreads. So this can be done by combining all these three domains. That means at what velocity the impact will be over the region. So this is a one small example I gave why there is a combination of all these three technology. And most important, you need to use supercomputers because the data are not just MBs or GBs, it is terabytes of data. You need to have time factor. Within shortest possible time, you have to derive the information. So HPC simulations is unavoidable. So what is the thing? So perfect input STL file to decide the quality as well as accuracy of the real-time and real-time HPC results is feasible only when this approach is followed. For now come to the FOSS. For geospatial model, to what extent I will be able to get that STL? That is all. Because why? Because now everything has to be made in India. We have to do have our own things. So much efforts is getting diverted in that. So much of my efforts now previously I go GIS STL file straight away to derive. When I use CORS JS straight away to the computations. But now much of my efforts goes on CAD level to improve the STL geometry of the objects for which I need to analyze. That is most important. So if you take ASAN today, any publications on urban analytics on using CFD model, they'll suddenly use GIS, suddenly use 3D, but if you see, all the publications are vertical exaggerations. All the publications are, I have seen last 3 days also. They talk vertical exaggerations, buildings are square, rectangular, but actual geometry of the buildings never been captured, even at micro scale level. There is a scale difference between GIS, scale difference between CFD that I'll cover at in subsequent slides. So till today, there is no single publications which works at micro scale level of a urban environment. So why it is, why should I work at micro level? To design energy efficient buildings, especially HVAC, heat, velocity, air conditioning systems. These micro level studies are very much useful. So now I went for the case study. I told when we were working on it, we were working simply whatever the data we get from the client and we will simply fire the job and HPC cluster will get. I told no, whatever the result we are giving, it's not up to the mark. If you use on the real ground implement, there will be a variation. Why? No, it is the, what is these vertical exaggerations? The flow we are calculating on the vertical exaggeration, not actual on real field environment. Then how you will prove? Just I taken my own building where I sit in CDAC, and this is the Baipanalli region of Bangalore, and these are the metro stations, and the two red color buildings, which is these are my buildings. That means where I sit. Now I moved to Electronic City. So these regions, I told I'll do a case study. I'll prove that we are not doing a real time what actually the flow dynamics is happening in real time. So I take my own building. I just able to get only Z parameters for each building. I went to QGIS. I myself has digitized, took the Z, what is the elevation, and everything I need to use open source. I should not use commercial tools, and developed a 3D of the building. Now here the question is, once again, I'm not getting the shape what I want. My building curvatures and my adjacent buildings, metro buildings, all these things, if you see, I know how it is. But no, it is not happening. It is happening as good as whatever publications I see. So where things are going wrong. So what I started to play with the various parameters within the constraints of QGIS. So QGIS right plugin is STL, shape to STL is the plugin, which is the one which I am using. So these three parameters I have control on that, spacing, scale, and exaggerations. So there are many experiments I have done, and one particular parameter purposely I have not captured. I want to see whether anyone is going to ask that one. So mesh space constant and varying scale, I did so many experiments. And similarly, I kept varying mesh space and scale as a constant. So various experiments I did. In all the experiments, I could get only these inputs. These are the outputs. I am not getting when I increase all the parameters also. So what exactly happening? Then I went to the checking the geometry statistics of each one. If you see the geometry statistics, it increases when I increase the parameters, increases. But why it is not reflecting in the final output? Where things are going wrong? So I could not get it at the beginning. I went for the commercial software. I experimented with the same parameters. I could get the curvatures. Some amount of good curvatures, I got curvatures. So it is happening. There is no problem with my input file. There is no problem in my things. So somewhere something wrong in FOSS. So then I found it. What happens is when it goes to fire more on heavy jobs, the tools which we use is supports less than 2 MB everything. When you go more than terabytes of data, gigabytes, it will take time. Time is the factor which I have not captured in my table. Because time is the most important thing which we need to do it at the earliest. But FOSS, when I use, I'm not able to get it within, I need within half an hour, 1 hour. That is not happening. It takes days. So when I see the rendering is so bad, that means the exact problem lies at visualization pipeline of respective tools. This doesn't mean those tools, whatever I used, FreeCAD and Solomon and other tools, is bad. But FreeCAD and Solomon are mechanical engineering tools, which cannot compute analysis related to urban modeling. So this is why it is doing, and I'm also able to get geometry, but the visualization engine of respective tools is not able to bring the output in a curved, as it is. That is the thing I found. So that is the reason we need to completely reformat, come out a new tool. This is the one which I decided. And still today I spoke, still now I spoke about GIS and CAD. Now I'll come to the CFD. Whatever input which I got, I should do that. This is not the commercial input, this I'm not using. So whatever input, I have to use what is the computational fluid dynamics, what I'm going to do. So in computational fluid dynamics, there are 3 steps major importance: pre-processing, post-processing, visualizations. All 3, once again, I have to use only open source. I cannot use commercial tools. There is an open source called OpenFOAM. That is the #1 tool in CFD, open source tool. And I can say, as of now, there is equivalent tool. I'm not finding anything else. So pre-processing, there is something called meshing. It happens. What it happens is whatever the STL file which you give, it will divide into mesh. And there are n number of meshing parameters are there. The SnappyX mesh I decided because I want the get results quickest possible time. That is one of the reason I took SnappyX mesh. And also in computational file, in GIS, we work in 2 dimension and covering entire area. You have to define Z factor also. What is the flow, up to what height, and what is the flow extent. These things you have to design. That in all case studies, your computational fluid dynamics results are bounded by these boundary factors. So the inlet is nothing but where my airflow, what is the airflow, output it is what I am going to get. Top is from my building 20 meters I exaggerated. That is my boundary level. So beyond this anything, it will not give, result will not give. And beyond this you have to increase the parameters. So as I said, when I come to computational fluid dynamics, 200 plus almost CFD solvers are there. They are mainly known for the very, very complex algorithms. I took a simple algorithm of RANS epsilon model. So these parameters you have to derive. What are the parameters? Kinetic energy, energy rate, and field. So these, as I am as a, this one, I need to depend on the sensors. So I have to ask my IoT sensor team. They have the specialized instruments to detect the velocity or other parameters of the IoT team input I took, and they placed the sensor on the CDAC inflow side, wherever the air inflows comes. I took the parameters with the help of those sensors, K, epsilon, as well as P parameters. The initial pressure is always been generally kept as 1. In almost all, still today, I have not seen a urban modeling paper where the initial pressure is going beyond 1. So this output is from an open source tool called ParaView. This is a visualization software which we use. So my inlet is that side. These are the low resolution STL files. What happens when air flows at what rate, what velocities. This is the one. Here the biggest thing is missing is the scale. The scale one which gives the at what velocity. But my publication paper, it has that scale. Since it is a video, I will not. And it has its limitation. The same visualization when I do analysis, open source, fantastically it will come. The same parameter, same thing. But now we are forced to work on the Made in India concept. So we are exploring our things. So still now I covered introduction and case study. Covering all. What are the findings over this? First finding, I'm not reading here, I'll put it here once again. Whatever is there, we are doing existing flow dynamics, airflow dynamics, whatever it is, we are doing a vertical exaggerations. We are not doing on the ground reality. There is a drastic difference, which I could able to prove with my own building, doing my own building, which needs to be improved. And when you work always urban dynamics, urban modeling, you need to work less than 100 meter to maximum a kilometer. The days are gone where almost kilometer by kilometer to 10 kilometer and more. Urban dynamics is very dynamic. You have to work at building scale level to micro scale level. This is the range which you will have. So amount of data generated is unbelievable, and it is very hard to store also. That one. This can only, when you work such a high resolution data, high geometry data, I can say high resolution, high geometry data only. Oh, sorry. When you work with such high resolution, 5 minutes, yeah, I'll finish it, I'm finished. High resolution, high geometry data only, you will be able to view real-time details about high energy HVAC details, parameters. And second thing is, this is the main thing which I'm trying to do. This convergence, I don't want to spend much time because so much of my time is going out. I'm trying to work this one. Straight away, I have to increase the shape to STL QGIS plugin in such a way it gives 3D in a spectacle manner. I should be able to use this. I have browsed, anyone has attempted like this. Only 2 members I could see. One is on 2014. Someone is attempted for only taking the 3D printout. So only one. This is another, the person who developed that QGIS plugin. If I achieve this, almost half of my time I can be saving that. And third one is, you might have seen that time consuming and FreeCAD is not supporting, software is not opening. I need to work with the visualization pipeline of the software for which I'm going to visualization pipeline such a way it will enhance my visualization in realistic way. These are other minor objectives, which is, let me come to the summary. The final study mainly focus on bringing out the interoperability related issues faced during GIS, CAD, and fluid dynamics based HPC models. And all the way I have used FOSS tool and demonstrated with my own area. And future I need to work with a visualization engine as well as CAD geometry so that particular plugin can be developed and can be part of the QGIS. I'm really desperately looking for highly specialized manpower in that region. So once it reaches, I can give them any pollution disbursement of any region, maybe within 40 minutes, 30 minutes, like that, when I use HPC. This is my challenge I'm moving at. With this, I'll thank my CFD team, who is not there here, Jani Raman and Smith Kumar, my executive director, Sudarshan sir. The project which has funded to me is National Supercomputing Project, National Supercomputing Mission, and my own ministry, Ministry of Electronics Information Technology. Thank you.
Thank you so much for this interesting presentation. I learned a few things. Any questions?
Nowadays we have the drone LiDAR. So if you fly the drone LiDAR, maybe you will get a very, very strong, good data, I think. No?
What happens is when you flow drone, it gives one angle only. You need to go vertical, but that will work in European countries. When you go in Asian countries, it gives one angle data only. So another angle, we are trying to building mass index, very simple. We are trying to match this drone data, which is being collected from one angle. Another, we are trying to make building mass index. We are trying to evolve, which is still yet to be started. The building complete 360 degree I should have information. Complete 360 degree of the building I should have. Definitely we can do it, sir, but in Asian countries, when the drone flies reverse direction, adjacent building will be hiding the first building. High-rise building, it's not a problem. But in Asia, almost you can not have everywhere high-rise buildings.
Yeah. I just had a query. I mean, you're talking about CFD in terms of buildings, but
Okay.
also you mentioned that you could do kind of flood mapping in case of a dam break and pollution.
Yeah.
So, I mean, in terms of my understanding, that is basically a closed model. It's got 4 walls.
Okay.
Computing for that is, I think, different. It will be different as to doing it in an open space.
Okay.
So, in what way are you going to be collecting data in open spaces, like pollution dispersion or?
Let us take the stubble burning of this one. So I know so and so once the stubble burning is happening. So the field data will, that means the particular locations I will get it. That pollution data has to come from IMD only. There are sensors has been placed, which is strictly monitored by pollution boards. Those data they will give it.
Okay.
Only thing is at what height you want, that we will ask the question. You want the because that stubble burning will impact the Delhi.
No, that's okay.
So
that's
what
okay.
height,
Yeah.
and the data is from pollution control board, which they give.
No, my question is slightly different. What I'm trying to understand is when you talk about computational fluid dynamics and fluid flow. Fluid flow is essentially we are describing in a closed environment. It could be a pipe or it could be a building or whatever.
Yes, yes.
But when you're talking about pollution, whether the data is from IMD or anywhere else, that's not the point. It's not a closed.
Sir, actually that is the reason these boundary conditions which are shown.
So you're defining even in an open space the boundary conditions. Okay.
Okay. Beyond that boundary, I cannot. Whatever I define within that boundary, my algorithm gives the result.
Okay.
I have to define the boundary conditions.
Yeah. Thank you.
Thank you once again for this interesting presentation, Manavalan. If there are no any further more questions?
This is the boundary conditions. I have to define. Yes, yes. Thank you very much.